I'd like to do a quick introduction to alkyl halides before we start talking about their reactions. Let's just review some of the things that we already know about alkyl halides. You should remember that they are moderately polar molecules, but there's a range of polarity depending on the identity of the alkyl halide. Remember that fluorine is the most electronegative of all of the elements and the most electronegative of the halogens. As you go down in the periodic table within this family, electronegativity decreases, and by the time you get to iodine, electronegativity is not very high at all. They have higher boiling and melting points than hydrocarbons, and this is by virtue of their polarity and also their size. But their boiling and melting points are not as high as those of alcohols of similar size, and that's because alkyl halides are not capable of forming hydrogen bonds. They're insoluble in water, again, because they can't form hydrogen bonds with water. They are soluble in organic solvents. You may not realize it, but we use alkyl halides for a number of purposes. Probably the most familiar is as refrigerants, and you've probably all heard of Freon. Alkyl halides are useful as refrigerants because they have a very high heat of vaporization. In other words, they can absorb a lot of heat. We use them as propellants in various consumer products, hairsprays and such. However, CFCs are no longer used for these purposes in the United States, and their production has been banned. We do still use alkyl halides as pesticides, and you may have heard of ethyl bromide. Ethyl bromide is used as a fumigant, and this is one of the pesticides that's used when people have their houses fumigated and you see the tents on top of their house. It's highly toxic. Alkyl halides are also commonly used as fire retardants because they are not flammable. So in the presence of a fire, say in a laboratory, that area will be flooded with an alkyl halide fire retardant such as halon. You better make sure you get out first or you might suffocate. You may not know that we use alkyl halides commonly as anesthetics. Things such as halothane and the fluorines. These are gases that are administered often during surgery. There's a lot of concern about this use of alkyl halides, as a commonly used anesthetic, desflurane, has a 100-year global warming potential more than 2,500 times that of carbon dioxide. These gases are generally not metabolized in the body. They're vented out into the atmosphere, but we don't really have good alternatives to these anesthetics. Well, let's talk about some of the other uses of alkyl halides. For organic chemists, alkyl halides are extremely useful as starting materials for organic synthesis. This is because alkyl halides can be converted into many different functional groups. We make them from alkanes through a radical halogenation reaction. We'll talk about this reaction a little bit later, but they're essentially substitution reactions. And you may remember that I once told you that alkanes are highly unreactive, and that is true. And this radical halogenation is the only practical way to introduce functionality into alkanes. So we start with our alkane, convert it to an alkyl halide, and from alkyl halides we can make many different kinds of molecules. Let's consider the properties that influence the reactivity of alkyl halides. Carbon and the halogens have different electronegativities, and this results in a carbon-halogen bond that is polarized, or in other words, we have a separation of charge. Carbon is at the positive end of the dipole, and nucleophiles are attracted to this positively charged carbon. So if we look at the electron density maps of some of our alkyl halides, we have chloromethane, bromomethane, and iodomethane, you can see the differences in electronegativities, with the carbon chloride bond being the most polarized of the three, and the carbon iodide bond only slightly polarized. Recall that we classify our alkyl halides as primary, secondary, and tertiary. And you'll see a little bit later on that one of the reasons that we do this is that their reactivity is different. So classifying the alkyl halides allows us to predict what types of reactions they will participate in. As I mentioned earlier, our carbon-halogen bond is polarized, with carbon at the positive end, and nucleophiles tend to attack this positively charged carbon. There are two important types of reactions of alkyl halides that we're going to be talking about. Those are nucleophilic substitution and elimination.